Hello, my name is Elena Volodina and I am presenting today a paper CoDeRooMor, a new dataset for non-inflectional morphology studies of Swedish. This work has been carried out together between myself, Yusuf Ali Mohammed, and Therese Lindström Tideman, and we represent two universities, University of Gothenburg and University of Helsinki. The work has been done in the context of a project L2 Profiles for Swedish, which is a nickname. The full name is Development of Lexical and Grammatical Competences in Immigrant Swedish, and it is funded by Riksbankens Jubileumsfond. At the bottom of the page you can see a link to the website for this project. The link to the presentation is here if you wish to follow the presentation or have access to all the information that is being given here. And now to the content. What is CoDeRooMor? The name of the resource reflects its nature. It is about compounding, derivation, and root morphology, and more. It is a dataset of 16,230 Swedish words analyzed manually for inner word formation structure, and as such, it is a gold data resource for word formation morphology of Swedish. The resource is freely available from the link that you see at the bottom of this page. And it can be downloaded in two views. The first view is Lemgram view, where you can see for each individual item in our list all the information that is associated with it. Its sense, its part of speech, analysis, manual analysis for all those root, prefix, suffix, and so on, kind of word formation analysis. We provide also segmentation patterns, so segmentation where borders go, patterns of how this is structured, like for example prefix, root and suffix here. We have real root information, which means that we're linking together two different potential allomorphic variants of the same morpheme, of the same root. In this case, for example, adla and adel are the two variants of the same root. Then we provide word formation mechanism, and finally we provide the level of the kind of text where the word was observed for the first time. And this level is provided in CFA terms, where A1 is the lowest level, the beginner level, A1, A2, B1, B2, and C1 is the most advanced level that we have represented in our data. Another view is morpheme family view, where we structured all the items by morphemes. For example, on the top row you can see morpheme A, which is a suffix, and there are 1,600 items that are linked or that have this morpheme in the words. And you can see here, for example, leverera, lugna, say, meditera, verbs that have suffix A, but even nouns, narkotika, pumpa. This means that actually this morphemic family is ambiguous. We need to disambiguate it into several subfamilies, which is some work for the future. It is also kind of true that you will have the same word entering different morphemic families. Like for example, the word meditera it is a member in the A family, for suffix A, but it also is a member for er suffix family, and it is also a member for its root, and so on and so forth. So the word can be appearing more than once in this case. So why did we do this resource? It was inspired by the kind of project itself. We are studying learner language development, and complexity is used very often as a proxy for learner language development. And there is one model that we especially favor in this case, which is COF model, which stands for complexity, accuracy, and fluency. Accuracy and fluency are outside our studies. Accuracy stands for how many errors and how many correct occasions of certain feature learners have. Or fluency is how fast, for example, they speak or write, and how often they have to correct themselves. We're looking into the complexity, which is actually what kind of linguistic features learners are able to use. Complexity, in turn, is split into several dimensions. One is referring to the individual learner characteristics such as memory, motivation, language aptitude, health. And another one is a more or less formal property of a language, which is linguistic complexity as such. And this one falls into, again, several dimensions. We have phonological complexity, morphological complexity, lexical complexity, syntactic complexity, and potentially other types of complexity that are being developed, or like phraseological complexity, for example. This resource is aimed at morphological complexity. And again, morphological complexity is not a single thing. It falls into several dimensions. We have inflectional morphology, which can be studied using the output from the automatic pipelines for language annotation. So, and this is outside this resource. We are studying word formation morphology, and here we are concentrating on compounding, affixation, word families, and morpheme families. Once we have both in place, we could look into a third type of morphological complexity analysis, which is a distance index between the first language of a learner and the target language that learners have to study, like how different the morphological structures of these two languages are. Within the second language context, this resource can be used for example, studying relation of morphological awareness and language proficiency, or just awareness of derivational morphemes as such, priming effect of roots on learning new vocabulary and the speed of learning new vocabulary, for example. Vocabulary testing, it can be used for pedagogical applications of different kinds, for intelligent computer-assisted language learning, for example, for development exercises, and so on. Outside second language context, it can be used for topological studies, for computational complexity studies of languages, for psycholinguistic studies, cognitive studies, machine translation, cognate identification, and so on. And we believe that this kind of, given the goal nature of this resource, it would be stimulating research in these areas, or we hope that it will stimulate research in these areas. To give you an idea what this resource is like and whether it's kind of reliable for you to use it, we provide you some information about how we did it. So first of all, what kind of lexical items we have on our list. Of course, it depends on the source data that we're using in the context of the project. So we have two learner corpora that we have used as a source of data. One of them is textbooks that learners are reading in the courses of Swedish as a second language, and the other one is essays, corpus of essays, well, pilot corpus, essays that are written by learners of Swedish as a second language. And both corpora represent several levels, from A1 to C1, from beginner to advanced levels. And originally, we generated two word lists. One was based on the textbooks, which represent the receptive vocabulary, and the other one was generated from essays and representing productive vocabulary. And these both resources were generated on the Langram basis. Later, when we had a possibility to word sense disambiguate automatically, word sense disambiguate Swedish words, we have used that opportunity to regenerate those two word lists, which resulted in a sense starlix. Sense stands for sense, sense-based, and star stands for sva lex and swe lex in one. So we kind of have one resource representing both types of vocabulary. And it covers 16,000, a little bit more than 16,000 items, sense-based senses, so to say. And we believe that this is pretty all-covering for the modern vocabulary, because these are the most frequent items in Swedish. So we think that the selection of items is very relevant for other types of projects as well, outside second language context. We have used several categories for word formation, among others abbreviation, compound, derivation, lexicalized forms, root morphemes, and lexemes, and unknown. Lexicalized forms are those that have inflected forms even as base forms, like, for example, Aftonbladet has an inflectional ending, Jens Spikar has an inflectional ending. Unknown ones are very difficult ones to understand how to analyze, and very often we did find a way to link them to one of those more recognized word formation mechanisms. but in certain cases we have left it as unknown. You will not find here, for example, blending, which you could just meet, for example, in some linguistic literature, because we didn't have any reason for including this based on our material. Doesn't mean that it doesn't exist in the language, of course. Then another category that we have been working with were morpheme types, where we have included derivational prefix, root, and its allomorphic variant, real root, derivational suffix, infix, which is Swedish full G morpheme, inflectional suffix, and again here we have unknown, where possible we tried to reduce it to one of those above categories. To support annotation, we have implemented a tool, Legato. The link to Legato is provided down here, and it offers support for annotators of different kinds, guidelines, skipped items, filtering, information from pipelines, examples, even kind of analysis that is provided in Swedish academic word list, for example, lexicon of modern Swedish. To give you a feeling for the annotation quality, we have calculated inter-annotated agreement using Krippendorff's alpha. There were four annotators, 3 annotators and 1 researcher who was leading the work, and they have been meeting every week for 4 weeks, for 1 month. They have been doing the same 100 words each time, and they have been kind of looking through and trying to agree with each other on disagreements. And from week to week, the performance improved, and the guidelines have been developed and improved further and further. And what these numbers tell you is that different annotation types, segmentation, labeling, word formation, and joint segmentation and labeling have very high level of agreement, which means that all annotators have been agreeing very well with each other and very well with the guidelines, which probably doesn't mean that you will agree with our guidelines. That is the reason to look into our guidelines and see whether this actually is something that you want to work with. So what can be done with this resource? We can do statistic analysis of second language or Swedish language if you want to generalize. We can see, for example, unique count for different morphemic categories, how they appear in the vocabulary list and how they appear in the running text. We can relate those frequencies to levels and see how different features, linguistic features, morphemic features appear at different levels. We can study derivation complexity. Here, for example, you can see the third row from top that the number of morphemes per word is growing from A1 level to C1 level, which is kind of a nice progression here. We're working on setting up a resource of possibility user interface for users to kind of browse Swedish morpheme family and filter, see a statistical view, graphical view, and download this. And the same refers to Swedish word family, the resource that has never been yet generated for Swedish, and now we hope that it will be of interest to many different types of research questions. And ultimately, we would love to develop automatic tools for using CoDeRooMor. We want to develop automatic tools for detection of morphemic boundaries, labeling morpheme for their types, and labeling words for their word formation type, with the ultimate hope that this type of automatic tool can be added to automatic pipelines, primarily to SPARF, so that more corpora could be annotated with this type of information, and more research could be supported around morphological word formation of Swedish. With this, I want to thank you for your attention. If you have any comments or questions, you can mail to me. You see my mail here, or you can mail to my co-authors. You can open the page, the paper, and see the emails there. You can see the link to the presentation here as well as to the dataset. Thank you once again.